For this video, let us try to solve for the three reflections of point X along the lines L, M, and N. Specifically, we are given with this notation. Okay, you have N, M, and L. This means we're going to reflect it to L. The result will be reflected to M, and then the result will be reflected to N. That would be the three reflections of your point X given as 6 and -1. Now, to really look into this perspective and to look at the picture, let's plot it on the Cartesian plane. Okay, because we can see here that our X is at 6, 1, 2, 3, 4, 5, 6, considering that all grids are at 1. This is our X at 6 and -1. And we're going to take its three reflections passing through line L, M, and N in that specific order. We need to graph first the L, M, and N lines so that we would know how do we picture the specific reflection. But before we continue, let us not forget, as discussed in the previous video, when we talk about the three reflections, it is actually a combination of a reflection and a translation. So at this point, we will be combining all the things that we have learned, because first, we're going to reflect that certain point X along line L, and the result of that will be taken into 1, and you will be subjected to a translation along line M using N. Okay, so again, let's graph this three lines. So pardon if we will take time on this, if you don't want to really look into the process of graphing these three lines. You may jump to a specific point in this video where the graphs are already presented in the Cartesian plane. So to graph that, let's start with X. I'm in L, X minus Y equal to 6. For your X-intercept, okay, we actually let Y be equal to 0. So we have your X minus 0 is equal to 6. X is 6. So your X-intercept is at 6 and 0. For your Y-intercept, let X be equal to 0. So you have here 0 minus Y is equal to 6. Negative Y is 6. So Y, is -6. Therefore, we have here at 0 and -6. These are the two intercepts for our first line. Second line, M, is X minus Y equals 3. So you have your X minus Y equals 3. So for our X-intercept, let Y be equal to 0. X minus 0 is 3. X is 3. So the X-intercept is 3, 0. For our Y-intercept, we have here let X be equal to 0. So you have 0 minus Y is equal to 3. Negative Y is 3. Y is -3. So you have here 0 and -3. For your N, we have here this. X minus Y is equal to -3. Okay. So you will have here let Y be equal to 0. X minus 0 is -3. X is at -3. The X-intercept is at -3 and 0. For your Y-intercept, let X be equal to 0. 0 minus Y is equal to -3. Negative Y is -3. So Y is +3. So 0 and 3. Now that we have their intercepts, we can plot them now on our Cartesian plane to see the graph. So the first one is, of course, for our line L, 6, 0. So it's actually here. And 0, -6. 2, 3, 4, 5, and 6. Okay. This would be our line here. Our line would compose of the 2 points. Hopefully, I could connect them well. Okay, let me try again. Okay, using a better line. Okay, so let me try to connect them into one attempt. Hoping that my attempt is already okay. That's for our line L. For our line M, you have 3, 0 and 0, -3. So 3, 0 is somewhere here and 0, -3. Connecting them, this would be our line M, assuming again that my graph is okay. Okay, assuming that is good. So you will have here, this is your line M. Okay, and finally for your N, you will have here negative 3, 0, 0, and 3. So negative 3, 1, 2, 3 is 0, 0, and 3, right? Negative 3, 0, 0, and 3. So the third line is actually somewhere here. Sorry for that. So, again, assuming that my lines are actually parallel, because they must be parallel, okay, n, because you can see that your slopes for L, N, and N are actually the same, okay? So there are actually parallel lines. These are our different lines, and of course, as you can see, the closest line is L, so it's really correct that we are going to reflect it to L first, so probably somewhere here, and later on translate it to our N. Or again, the other method is, of course, you use double reflection after your first reflection, hence 3 reflections. But let's try to use the method of getting first reflection before your translation. Okay, so let's talk about now its reflection, talking about point X along line L. Okay, and then later on, whatever be the result, we're going to translate that using the formula for translation. Take note that the formula for our reflection is actually X minus twice. You have here the inner product of X minus P and your unit normal vector times your unit normal vector. Take note here, we know what X is, okay? But what we don't know here is actually P and the unit normal vector. As for your unit normal vector, we can actually solve that first by identifying our normal vector. If we're going to return on our given, take note that we can identify our normal vector using the A and B coefficients of your equations. This is also true with the rest of the equation here. Our A is actually 1 and our B is negative 1. Hence, our normal vector is at 1 and negative 1. Or in parentheses, you have 1 and negative 1. Similarly, the length of that is actually the square root of the sum of the squares, 1 squared, negative 1 squared. This means it's actually square root of 1 plus 1 square root of 2. This is the length of our normal vector. We need this too because to solve for the unit normal vector, it's actually the ratio of your vector n over its length. Okay, so the n in parentheses is actually 1 and negative 1 over the length, which is square root of 2, or then of course write in this manner, 1 over square root of 2 and a negative 1 over square root of 2. This is the normal, the unit normal vector intended for the reflection of X along line L. And at the same time, since line L, M, and N are parallel lines, if we're going to talk about a certain normal line is perpendicular to 1, assuming it's true, it's also perpendicular to all. This means that the direction vector of this normal line, we call it the normal vector, is also the same with respect to all the parallel lines that is being perpendicular to it. That would mean if we're going to use another form later on or formula which will use the unit normal vector, we will still use the same unit normal vector in this form. Anyway, let's start first with the reflection of X along line L. So again, we know what X is. So our X is actually identified as 6 and negative 1. So you have here 6 minus and then minus 1. Then you have here minus twice the inner product of 6 and negative 1. How about our P? How do we identify our P? Now this is on with respect to our line L, we can actually pick any point on line L. But since we already have our intercepts, let's pick an intercept. To be consistent with what we did in the previous examples and previous videos, let us of course choose x-intercept. Of course, you can use y-intercept if you would like to, but as long as you try to make sure that you are going to manipulate that carefully. But just to be consistent, let's just use x-intercept if necessary and if available. So in this case, 6 and 0. So if you're minus 6 and 0 times unit normal vector at here at the bottom, 1 over square root of 2, negative 1 square root of 2, inner product of that, times the same unit normal vector. Okay, so we are going to simplify this first, that inner product. So we will have here 6, negative 1 minus 2, and then the result for this first. So still have the inner product of 6 minus 6 is 0 and negative 1. Okay, you have 1 over square root of 2, negative 1 square root of 2, inner product of that, 1 over square root of 2, negative 1 over square root of 2. This will give us still 6 and negative 1. You have here minus 2. As you try to get the inner product, you'll be multiplying the components. But take note, you're going to add them. Hence, you will come up with a scalar result. 0 times 1 over square root 2 is just 0. That would mean what remains is the second components. Negative 1 times negative 1 is just simply positive 1 over square root of 2. Times, again, your unit normal vector in this manner. Okay. Now, to continue, so you will have here this result now. So you will have the form 6 and negative 1. You have here minus. You're going to multiply this entire scalar together with 2 in each of the components. So 2 times 1 is 2 times 1. So you will have here 2. Sorry, let me use black. Okay. So you have 2. And as you multiply your denominators, it will be rationalized over 2, right? For the second, 2 times 1 times negative 1 is negative 2, and you have here 2. Okay? That would mean our result here is actually equal to, okay, you will have here 6, negative 1, right? So you will have here minus 1 and negative 1. Hence, the reflection of your x along line L is actually identified by 6 minus 1, that's 5, and negative 1 minus negative 1, double negative property is 0. This is the reflection of point x along line L. So in our graph here, we're going to reflect this along our line L. We would see that this is actually our reflection. Okay? But that is not yet the answer because we're talking about 3 reflections. What we have here is actually just the first reflection. We will be using this, okay? We will be using this to identify the next process. Because this will now be considered as the point here, which will be translated into along line M and of course line N. Okay? And take note, we are done with the reflection. As for the translation, we will be using the formula for the translation as well. So allow me to add a page here, another page, for us to scribble the next process. Take note that we are done with our this one here, the reflection of x along line L. We know that our x is at 6 and negative 1, but its reflection along line L is actually 5 and 0. The next part is actually to complete this process, okay, the 3 reflections, where we consider this as 1. So if we're going to let the said reflection into y, so mean this would be y, what we have here is just the notation for translation of your y along line M rather. Okay, and for that we have the formula for the translation. We have actually x plus twice p minus q. But since we are talking now about point x no longer, point y no longer point x, so allow me to change the formula here. So this will become y now, and the next big thing is for us to identify p's and q's. Okay, because after this point we just simply need to identify p's and q's. Our p is actually the foot of perpendicular, on which line? Going back on our graph, take note that this the closest line aside from L to the point of our first reflection is M. Okay, so our point P, it must be somewhere here on N. Okay, so it would be on your N using Q on our M. So we will be picking Q, okay, a certain point Q on our M, and then later on identify what would be its foot of perpendicular pertaining on our line N. And earlier we chose the x-intercept. Again, to be consistent, let's use the x-intercept for our Q as well, 3 and 0. So you will have here 3, 0. We know already now our Q. Our Y again is this, but let's identify first our P, which would stand for our foot. The foot is actually identified by the formula x minus, you have here the inner product of x minus p in the same unit normal vector. Okay, and then you have here unit normal vector. But take note, again, we are no longer using x. At the same time, in the context of translation from this point on that, we will not be using x anymore, but we will be using this point, okay, to represent our point after reflection. What would be our x now? So how do we revise this? Our x is a point on, okay, our closest line M. So we're going to choose here Q minus, you have your Q minus, instead of P, so this would be not be confused. Our P here, not the P that we're trying to solve as a foot of perpendicular, nor not the P that we used here. Okay, let us use P as the intercept in N on the second line. The unit normal vector here, and you also have the unit normal vector. We know already the unit normal vector to be this, so allow me to copy that here. So our unit normal vector is actually identified as what was that, 1 over square root of 2, negative 1 over square root of 2. So our intercept for N, okay, our intercept for N, again, to be consistent, let's use the x-intercept here. So negative 3 and 0. Now that everything is already okay, let's now solve for our foot. Our Q is at 3, 0, minus 3, 0, minus your intercept on your N, negative 3 and 0. Okay, we might see some good news here, as we might have zeros later on as we multiply this to our what do you call this one, our unit normal vector, which is identified as 1 over square root of 2, negative 1 over square root of 2, times again the same unit normal vector. This is actually 3, 0, minus, as you can see here, 3 minus negative 3 is actually 6, right? 6, and then 0. And we'll have here 1 over square root of 2, negative 1 over square root of 2. Inner product of that, again, you have here your same unit normal vector. So you have here 3, 0, minus, and again, similar earlier, inner product. The second component will be 0. What happens, it will be the first, it would be 6 over square root of 2 times, it's now a scalar, again, plus 0. So you have here your unit normal vector. When you multiply that, take note, you're multiplying 6 and 1. So it's actually equal to 6 over the square root of 2 times square root of 2 is actually 2. And your other one, you have minus 6, and then you have here 2. This means that your foot, which stands for our P, needed for this entire formula, the translation, is actually identified as 3, 0, minus, you have 3, and negative 3. So our foot of perpendicular is actually at 0 and positive 3 now, because that's double negative property. Okay, this is the foot of our Q, which is identified as the x-intercept. So going back on our graph, our x-intercept is actually 3 and 0 here. So it's actually, it's what they call this one is foot is still this line here. Surprisingly, it's also the intercept of the other line, 0 and 3, right? But it should not be true for all. So since we're already done with that, that's the purpose is just to identify the proper P. Let's return to this formula here. Okay, so we'll have the final form. We actually had this notation earlier. Okay, Y. Okay, so you have Y plus twice P minus Q. Our Y is already the reflection earlier. So 5 and 0 plus twice. Your P is this one here, 0, 3, minus our Q here. So everything will come into order as we look into that. So you have here 5, 0, so plus twice, that's actually negative 3 and positive 3. This is 5, 0, so plus, negative 6 and positive 6. So our translation of our point y, which would actually be equal to the entire form where y is the reflection of x along line L, is actually identified as -1 and +6. This should be the result for the three reflections of the given item. Okay, but we use here the idea of the first reflection and a translation. Let's try to show if this is really possible. -1 and 6, so it's in the second quadrant, right? After we reflect it here, we reflect it there. So as we reflect it here, so basically, yes, more or less, we will get a point in the third quadrant, which is -1 and then 6. So that is the process of determining a three reflection of a certain point along the lines. Take note, since x is here, we start with the reflection along L. But if the point somehow is here, we will be using the reflection on N, and then later on translation to M with L as our last line, right? So it depends on how the point is plotted or where is it located on the Cartesian plane. So this is how you show the three reflections. We start with the reflection and then later on the translation using the foot. Or you could even stick to the formula of double reflection if you would like to. You simply try to replicate this 3 times. Either way, this is the correct answer for this item. Thank you very much for watching.